Hello everyone. Here we have a question on integral calculus. We are given the function f of x is equal to x plus 1 all over x minus 1 into x squared plus 1 to express f of x in partial fractions and then to find this indefinite integral of f of x with respect to x. So, uh, how do we do that? Solution. We have the function x plus 1 all over x minus 1 into x squared plus 1 to express in sum of its partial fractions. This should be the same as, if we look down there at the denominator, we have a simple linear factor and then a non-reducible linear factor. And so to express this as sum of partial fractions, the method is to write this letter a here all over the simple linear factor, and then the non-reducible, we write it in the form bx plus c all over x squared plus 1. Okay, how do we know this is non-reducible? You see, it's a quadratic, and from here, we know that a is 1, b is 0, c is 1. All right, for this to be able to give us simpler factors, the discriminant must be greater than or equal to 0. So if we look at the discriminants, we have 0 minus 4 into 1 times 1, and so we'll end up having negative 4. This is simply less than 0. It is not greater than or equal to 0. So it is going to give us imaginary roots or complex roots. So it is not reducible in the line of, in the field of real numbers. That's how we know. So for that reason, we express this as such for us to be able to split it into some of its partial fractions. So we have to solve for a, b, and c. These are all real numbers. Okay, now how do we go about that? We take the product of, we take the LCM of this and this. If you look at it carefully, it will just be their product, which is this one. So we're going to multiply all through by the LCM. We multiply here by the LCM, x plus 1, all over x minus 1, x squared plus 1, multiply by the LCM, which is x minus 1, x squared plus 1. We multiply all through by the same LCM, a all over x minus 1, x minus 1, x squared plus 1, and then plus b, x plus c all over bx plus c all over x squared plus 1. All of that multiplied also by the same, so let's do it down here, bx plus c all over x squared plus 1. All of that multiplied also by the same LCM. Okay, so if we come here, we'll see this will just cancel out that, and so we're left with x plus 1. And then here, x minus 1 cancels out that. We have a into x squared plus 1. And then, of course, here, we have x squared plus 1 cancels out that. And so this last portion will just be plus bx plus c into x minus 1. Okay. And so this is working all right. So we've seen how we progress from here to this point. So we have x plus 1 is equal to a into x squared plus 1 plus bx plus c into x plus 1. Now how do we get the constants a, b, and c? All right. If we look at this expression very well, we see that if we put x, to be 1, this is going to give us 0, and 0 multiplied by all of this will be 0. That will enable us to calculate the value of a. So let's just go ahead and do that. We say put x to be 1. The left hand side will become 1 plus 1 will be a into 1 squared plus 1 and then plus 0. Okay, let's write it out. Bx plus c into 1 minus 1. Alright, so we have 2 will be equal to 1 squared is 1 plus 1 is 1. So we have 2a plus bx plus c, all of that multiplied to 0, which will just give us 0. So we take it off then, we just give us 0. And so from here, if we divide both sides by 2, we will have the value of a to be 1. We'll find the value of a to be 1. Okay? Next, again, when we look at that expression, we're working from here. When we look at this expression, we'll see that if we put x to be, for example, 0, if we put x, for example, to be 0, this is going to be 0, and we're going to have an expression in terms of a and c. Since we already know a, we'll be able to get the value of c. So we'll say put x to be 0. When we put x to be 0, the left hand side will have 0 plus 1 is equal to a into 0 squared plus 1 plus b multiplied to 0 plus c into 0 minus 1. So this gives us 1 is equal to a, 0 is 0, multiplied to a, we have a, alright? 0 plus 1 is 1, multiplied to a, you have a. Then you come here, 0 multiplied to b is 0, and then you have the 0 minus 1 is negative 1, multiplied to c, negative c. Alright, since we know a is 1, and so we just go ahead and put the value of a. So from there, we'll subtract 1 from both sides, we'll have, all of it means therefore that the value of c must be 0. Alright, the value of c is 0. Now, how do we get the value of b? Alright, now to get the value of b, we just make any substitution for the value of x. We're going to end up with an equation involving a, b, and c. Since we already know a and we already know c, the only unknown that we'll have there will be b. So we'll be able to calculate the value of b easily. So if we say put, for example, x to be 2, if we put x to be 2, alright, the left hand side will just be 3, that's 2 plus 1 is 3, is equal to 2 squared is 4 plus 1, 5, so we have 5a, and then 2b plus c into 2 minus 1, which is 1. 2 minus 1, which is 1. And so from here we have 3 is equal to 5a plus 2b plus c. Alright, we know a is 1, and we know c is negative 1. So we'll take this negative 1 this way. We're going to have 4 is equal to 5 plus 2b. No, c was 0, sorry, c is 0. C is 0, and so we have 3. We have 3 is equal to 5 plus 2b. If we subtract 5 from both sides, we have negative 2 will be equal to 2b. Negative 2 is equal to 2b. If we divide both sides by 2, finally we obtain b is equal to negative 1. Okay, so we have the values of a, b, and c. A is 1, b is negative 1, and c is 0. So conclusion, we will now say therefore x plus 1 all over x minus 1 into x squared plus 1 as partial fraction will be, we found our a to be 1, so we have 1 all over x minus 1. We find our b to be negative 1, so you have negative x, and c was 0 all over x squared plus 1. Alright, this will just give us 1 all over x minus 1 minus x all over x squared plus 1. So that expression in its partial fractions will be 1 all over x minus 1 minus x all over x squared plus 1. Alright, that does it for the first part. Now the second part. We are asked to find the second part. We are asked to find integral of f of x with respect to x. Integral of f of x with respect to x. Alright, this will just be equal to integral of all of this. 1 all over x minus 1 minus x all over x squared plus 1. All of that with respect to x. Okay? Now, integral of a sum is equal to the sum of the integral. So it will be integral of 1 all over x minus 1 with respect to x minus integral of x all over x squared plus 1 with respect to x. Okay. Now, if we look at this first part, look at this fact, integral of 1 all over x minus 1, the derivative of the denominator is dx. So we can just give this conclusion here to be ln of x minus 1. Alright? Because the derivative of the denominator is found at the numerator. So this integral gives us the expression ln of x minus 1. Now, coming over here, if we carry out the same analysis, the denominator there is the denominator here is x squared plus 1. And we differentiate that, we're going to have 2x dx. But at the numerator, we have x dx. 2 is missing. So we can rewrite this expression putting that 2x dx. Okay, so if we want to rewrite that expression, we can do it as such. Instead of x, they will write 2x dx. But since there was no 2x over there, we remove it by dividing by a half. All over x squared plus 1. Alright? So we get ln of x minus 1 minus half. Now we can see that the derivative of this denominator is what we have up there. So it will now become negative half ln of x squared plus 1. Right? Now, some interesting thing again to note here. Here we have to put absolute sign, and here we have not used the absolute sign. Yes, because logarithm of negative values don't exist. Logarithm of negative values don't exist. So since we don't know the sign of x here, we don't know the values of x here, there definitely will be some values of x that will render this expression negative. So to guard against evaluating the log of negative values, we use the absolute sign function. Now come over here, no matter what value x take, the moment we square that value, we obtain a positive result. And since we're adding a positive result to a positive value here, this expression will always give us a positive value no matter the value of x. And so we don't have that fear of ending up evaluating the natural log of any negative value. So we don't need the absolute sign when writing this other expression. All right, since it is the indefinite integral, we must also include what we call the constant of integration. And so the integral of f of x with respect to x, integral of this function is the same as integral of the sum of its partial fractions, this integral, which will give us this result. It has to give us this result. Empty and message.